Hey, Algebra 2. Here is section 6.5, graph, square root, and cube root functions. Okay, we're gonna come back to this idea of radicals and stuff. We took a little break from that um, in the middle of the chapter for some reason with 6.3 and 6.4. But you'll kind of see why here in a little bit, like why those two sections were kind of put in this chapter, okay? So our objectives are to graph the parent functions for the square root and cube root functions, describe transformations of the square root and cube root functions, and then review domain and range, specifically interval notation, because now that we're in algebra 2, that's kind of the notation we need to be using, because you'll be using that notation a lot in whichever math class you end up going to after this, right? So we're going to start by talking about the parent functions, okay? So we have f of x is equal to the square root of x. That's our square root function. And then we have f of x is equal to the cube root of x. Okay. Remember back from 6.1 and 6.2, excuse me, another way to write this is x to the 1/2. And another way to write this one is x to the 1/3. Okay, those are the same. And kind of where 6.4 comes into this, the inverse, the section on inverses. Remember that the square root function is the inverse of the x squared function when we restrict the x squared, right? If I think about x squared, which is our parabola, if I ignore the left half and I just take the inverse, sorry, I kind of took away my axis a little bit. If I just take the inverse of the right half, then I end up getting this little graph, which we're going to see right now in a little bit, which is going to be the square root function, right? So this is x squared, half of x squared, and this is the square root of x, right? We need to get rid of 1/2 of it. Otherwise, the inverse is not going to be a function. We get the entire parabola flipped over, y equals x. And this right here is not a function, right? It's the same idea for the cube root. I take the cubic function, x cubed, okay, x to the 3rd power, and I reflect it across y equals x, and I get the same idea. I end up getting this cube root of x, okay? So now let's go ahead and graph these. Let's take a look and see what, why is it that they have that shape, right? So if I make a table for my square root function, I'm going to use specific values because I want to take advantage of the fact that it is the square root, right? So 0, 1. I'm not going to do 2 because 2 is not a nice square rootable number. It's not a perfect square. I'm going to skip to 4 just because I want to deal with just nice numbers for now. I could do 2 and 3, but it's going to be a decimal. And while that's not a bad thing, I'd rather just, I'd rather deal with whole numbers right now. And then the next perfect square is 9. Okay, so the square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Okay, and so if we were to graph that, let's see. Okay, I'm gonna make this a little bit longer actually. And I'm gonna scale this by 2 just because of the way the graph is. So -2, -4, 2, 4, 6, 8. Okay, so 0, 0 is right here. 1, 1 is right here, because 1 would be right here since this is 2. 4, 2, that's right here. And then 9, 3, 9 is right here, 3 is right about there. Okay, so then if we connect this, this is what our square root of x function looks like. Okay, and we kind of saw that just now with the little sketch that I made when I was talking about inverse of the parabola, right? I'm trying that again. I'm gonna try that again, see if I get a nicer looking one. There we go, that's a lot better. Okay, so here is f of x equals the square root of x, okay? And so let's kind of talk domain and range here, right? And let's practice with our interval notation. So interval notation for domain, we read left to right, okay? So you're gonna literally read like a book. So for domain, read left to right. Okay. So notice how I have absolutely nothing over here, and that makes sense because I can't plug in any negatives into my square root function, right? I can't have square root of -4. I can, that's just a complex number, and we're talking about the real numbers right now. So I'm reading left to right. So just go on the x-axis, read left to right. Where's the first x value you see right here at 0? And there actually is a closed dot here at 0. If it was an open dot, that'd be a different story. My graph is almost at 0, but it's not quite there. But it's very, 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 very close. Since there's a closed dot there, I'm going to use a bracket, and my starting point is 0. Okay, and as I keep moving to the right, my function is going and going and going, and this arrow indicates that it's going to go on forever. So then it goes off to infinity. Okay. And so then for my range, kind of the same idea, but for range, I'm reading bottom to top. So read, read, there we go, bottom to top, right? So then for my square root function, there's nothing here at the bottom because I don't spit out any negatives when I take the square root. If I take the square root of 10, that's positive. Square root of 100, that's positive, right? The first y value I encounter as I go from bottom to top is 0 again. So it's kind of the same starting point, bracket 0, because I do have a point there, a closed dot. And then I keep going and going and going. This arrow looks like it's going to keep going to the right, but it just keeps getting bigger without bound. It just continues to increase, okay? So as I read bottom to top, it's actually eventually going to hit all the y values. So this is also off to infinity, okay? So now let's talk about the cube root function, okay? So the difference here is that not only is it a different index, but my mind space for a bit, but you can also put negatives into this function, right? Because I can take the cube root of negative numbers. I'm allowed to plug in negative numbers into odd roots, okay? I'm going to be strategic here as well. I'm going to go up to -8, -1, 0, 1, 8, because those are nice perfect cubes. The cube root of -8 is -2, because -2 times -2 times -2 is -8. Cube root of -1 is -1. 0, 1, 2. Okay, so I'm going to graph this one as well. Okay, I'm going to need a little bit more room here. And I also want to do this in white. If it'll let me click my white, there we go. That's as good as it's going to get. Okay, so I'm going to put 2 up here. I'm going to scale the y-axis by 1, but then my x-axis, I'm going to scale that by 2. So 2, 4, 6, 8, 2, 4, 6, 8. Okay, so at -8, I'm at positive, just kidding, at -8, I'm at -2. What am I doing? At -1, I'm at -1, so right here. And then 0, 0, 1, 1, and then 8, 2. Okay, so the way this graph is going to look, and I should have done this in green. I'm going to do that really quick. This graph is going to look kind of like the square root function as well, but kind of 2 of them glued together like so. Okay, kind of like this, right? Notice how this right here, if I can draw it properly, this right here kind of looks like this, okay? But then as if it kept going from like into the bottom, into the negatives. All right, so there's our cube root function, kind of a crude looking one because I have a very unsteady hand, unfortunately. So for domain and range, okay, same thing, read left to right. Notice that there's an arrow going to the left all the way. So this is going to start all the way out at -infinity on the left, right? So from -infinity, and that comes from the fact that I'm allowed to plug in all the negative numbers I want. And then this one's going all the way out to positive infinity. So from negative infinity to positive infinity. And then my range, it doesn't look like it, but it is also continuing all the way down. It goes to the left faster than it goes down, but it's still going to continue downward because there is no asymptote. Okay, unless there's an asymptote, we're going to assume it's also going to keep going down. So from negative infinity to positive infinity, same thing. Unless there's a horizontal asymptote, we can't assume that it's going to stop somewhere in the y, and so it's going to keep increasing without bound. Okay. Cool. So there's our domain and range for the cube root function. And then something nice about this is that this is true for all cube root functions. And by that, I mean like transformations of the cube root. Okay, and you'll see what that means in a little bit. As for the square root, these can change. Okay, it'll have a similar look and feel, similar structure, but it's not always going to be 0 to infinity. All right, so general forms of the square root and cube root functions. This is going to help us to determine the transformations that are happening, right? So not all square root and cube root functions look like this, where it's just the square root and just the cube root. Okay, I can have extra stuff going on. Oops, wrong one. So for a square root, f of x is equal to a square root of x minus h plus k. Maybe that sounds familiar to you. And then for the cube root, same idea, a cube root of x minus h plus k. Okay, we've seen this h and k step before with our, the vertex form of a parabola, a x minus h squared plus k. And for rational functions too, a over x minus h plus k. Okay, the simple rational functions. This HKA stuff, it's very nice because it always tells us the same thing. A is a vertical stretch or reflection. Sorry, A is a vertical stretch or shrink, and then sometimes a reflection. H is left to right translation, horizontal translation, and then K is up and down vertical translation. Okay, so let's write that. Okay, and it's going to be the same for both. All right, so A, vertical shrink or stretch, and then sometimes reflection, and we'll talk about when it's a reflection. I didn't mean for it to go all the way over there. H is horizontal translation, and we'll say left/right translation. But then just know that officially it's called horizontal translation. And then K is up/down translation or vertical translation. Okay. So let's kind of see what that looks like in some functions, right? So for our example, describe the transformations happening in the root functions below, then graph in Desmos to find the domain and range. Okay, so we're going to graph these in Desmos. We're not going to be worried about sketching these so much right now. I think the important thing is for you guys to be able to identify them. If you see these graphs, you can think, oh yeah, that's a root function, either a square root or a cube root. And that's kind of the most important thing, right, for right now. So f of x equals 1/2 square root of x. What are our transformations here? Well, it looks like we have a, but no h or k. Okay, so if we were to describe this, our a is equal to 1/2, and what does that mean? Well, remember, if a is between 0 and 1, that's a vertical shrink. So vertical shrink. So think about it like squeezing down vertically, kind of like sandwiching it between up and down. And we'll see right now what that looks like in Desmos. So that is a vertical shrink by 1/2, right? We got to include the factor, the scale factor. Okay, so now that we know the transformation, let's go ahead and graph this just to see what it looks like. So I'm going to go to Desmos. Okay, so pull this up. I'm going to graph the parent function at the same time. So square root of x. Okay, there's our original function. I'm going to move to the left a little bit. Now I'm going to graph the transformation. 1/2 square root of x. Okay, so it looks, you can see that I kind of took like a weight and I squeezed down this red graph, which is our square root of x, squeezed it down vertically so that it becomes this blue graph, the 1/2 square root of x. Okay. Does our domain and range change at all? Looks like no. Okay, domain still starts at 0, goes off to infinity. Range still starts in 0 and still technically goes off to infinity vertically. It just takes a lot longer than most functions, right? But it's still going to get there. Okay, so our domain and range did not change here. So our domain is 0 to infinity with a bracket at 0. And our range is also bracket 0 to infinity. Okay, remember, I forgot to mention this, but remember at infinity, we always have parentheses because it doesn't, we can never actually have a point at infinity because infinity is just an arbitrary large number. Okay, just a random big number. So we don't really ever know what the size of infinity is aside from big. So that's why we always have parentheses there. Okay. Next one, 4 cube root of x. So what's our a here? It's 3. Okay. And we don't have an h or a k. So this one is a vertical stretch. Vertical stretch by 3. So then if you if you don't remember, so between 0 and 1, if a is between 0 and 1, that's a shrink. Vertical. And if a is bigger than 1, then it's a vertical stretch. Vertical. Okay. Cool. And then again, no h or k. And we don't even have to look at the graph. We will still, however, but we don't even have to look at the graph to know what our domain and range is, because for all cube root functions, it's going to be the same. Domain is negative infinity to infinity. Range is negative infinity to infinity. Okay, but let's still look at the graph. So Desmos. I'm going to get rid of, actually, I'm just going to get rid of this one and turn this one off because we'll come back to the parent function. Okay, to get a cube root, we need to go to functions, miscellaneous. We'll need to use this nth root and do the 3 in the index and then put an x in here. Okay, there's our cube root. I'll put it back to center since we have both sides. And we want 4 cube root of x. So we'll go back and grab the cube root, put an x here. Cool. So vertical stretch is like I'm taking the top and bottom with my hands and I'm stretching it up and down, pulling this green one upwards and this green part downwards so that it matches this really long stretched out purple one. Okay, I'm zooming out so you can see kind of the difference better. Okay, definitely a lot bigger compared to the green one. Okay, so then back to here. Now let's do C and D. All right, so C, we have some more transformations going on, it looks like. We already know the domain and range though, right? Cube root, automatic giveaway. But let's find everything else first. So A equals 3. H equals, remember it's x minus h. So that means that this h right here is actually negative 4. And then our k is negative 1. Okay, so what do these mean? Well, a equals 3, that's bigger than 1, so it's a vertical stretch by 3. H equals negative 4, that's a translation to the left by 4. So left by 4. And then negative 1, that's down by 1. Okay, so let's graph. I mean, we can already write down our domain and range though, because we have a cube root and range infinity to infinity. Okay, let's take a look at our graph. Okay, I'm gonna get rid of the purple one. I'm gonna do the new one. I already forgot. It's Q3 times the cube root. So I'm gonna need this one. X plus 4. Leave the square root, okay, because that minus one is not under the, or sorry, the cube root. The minus one is not underneath the cube root. So press outward so that it goes outside of the cube root, like so, okay? All right, so now notice what happened. Okay, I stretched it out by 3, so it became a lot bigger. And then I moved this green one. Think about taking this right here and moving it to the left 4, and then moving it down by -1 right here. Okay, so this new center ended up right here. It won't. There we go. -4 at -4 -1. It wouldn't let me pick this point, but there we go. Okay, that's our new center. That's where this point, this 0, 0, ended up. It ended up right here at -4 -1. Okay, so there's our new graph, and we don't need to talk about domain and range because it's the same. All right, last one. We have -2 square root of x minus 3 plus 2. Okay, so we have what? We have a is equal to -2, h is equal to 3, and then k is equal to 2. So a being -2, there's two things going on here. It's negative, so here's our vertical reflection. Okay, whenever your a is negative, that's when you have the reflection. And then we also have a vertical stretch because the number itself, without the negative, ignoring the negative for now, it's 2. So it's still a stretch by 2. Okay, so identify the vertical reflection and then ignore the negative and then look at the number. If this was -1/2, it'd be the vertical reflection, vertical shrink by 1/2, right? H equals 3, it's positive, so it's right by 3. K is 2, that's positive, so up by 2. All right, so now we definitely need to look at the graph for the domain and range because there's a lot going on here, and the domain and range of the square root function is subject to change. So let's take a look. Okay, so Desmos, I'm going to get rid of this bottom one here and then turn back on my square root of x. Okay, it was -3 square root of x. I already forgot the rest. And I was wrong, actually. This is -2. X minus 3 on the inside plus 2 on the inside, outside. Okay, I'm double checking to make sure that's right. Yes. Okay. So kind of look what happened, and I'll actually change the color of this one so you can see the difference. Let's do purple. Okay, so this is our original square root graph. What happened is I reflected this across the x-axis. Okay, vertically, I went and took this and I reflected it across, and so now it would be facing downward. And I can kind of show you the order. So this is the first thing we did. Okay, we reflected it, and then I stretched it. So I made that a 2. And then I moved it to the right. So -3 on the inside. And then we moved it up. Oops, I got to take this out of the radical. Plus 2. And that's how we got that function. Okay. And so that's where this point ended up right here. Okay, so this ended up all over here. Cool, so let's look at the domain and range. I'm going to turn off the square root function just so we can see a better picture. Our domain and range. Okay, domain, let's start there. Domain, nothing over here on the left. It's starting at the x value 3. So that's our starting point, and then it goes off to infinity. So we have bracket 3 comma infinity. Now for the range, remember we start bottom to top. Go from the bottom, go to the top, right? So from the bottom, it's going all the way down. It's starting down here. So it goes from -infinity, going up, 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 and it stops right here at +2. Okay, so instead of starting at a value and then going forward, it actually comes from negative infinity and it ends here at 2 instead of ending at infinity, right? So let's jot that down. Okay. Our domain went from 3 to infinity, and then our range started at negative infinity and stopped at positive 2. Okay, so there's our domain and range. All right, we kind of practiced this a little bit back when we did rational functions, but I kind of threw it at you. So here we're kind of spending a lot more time on it. So if you have questions about this interval notation, don't be afraid to ask. You should have learned it in Algebra 1, but it's kind of a more difficult topic. I can speak English. And it's been a while, right? So don't be afraid to ask about this because it is a little bit weird the first time around. All right, cool. There's 6.5. I'll see you in 6.6. Have a great rest of your day.